Good morning, ladies and gentlemen of our two honors. Good to have everybody here today. We're going to go into section 8.1, which has to do with finding rational solutions of polynomial equations. So you might recall in section 6.2, which we just finished yesterday, we ended up yesterday graphing polynomial functions. We talked about odd, even, end behavior. We talked about factored form and intercept form. And so how do we find the rational roots of a polynomial equation? We're going to start talking about that today and figuring out how to do that. Now, here we have the zeros of polynomial function and coefficients are related. Consider the polynomial function. And this is the type of polynomial function that we saw very much like that in the last section, right? And identify the zeros of the polynomial function. So we have this polynomial function here. What are the zeros going to be? X equals
2.
X equals negative 2.
1.
X equals 1.
And negative.
X equals negative 3, okay? And multiply the factors to write the function in standard form. Well, how do you multiply these factors together? One thing that we've done in this class before is something like this, right? Where we go ahead and say, okay, I'm going to multiply these two factors here first. So I'll put x minus 1 here and x plus 3. And so we get x squared minus x plus 3x and negative 3. And so from this we get x squared, and that's going to be plus 2x. Do you see that? And then minus 3. And now we can go ahead and multiply this last factor together like this. And so we have the x plus 2 factor here. And so we get x cubed, we get 2x squared, we get negative 3x, we get 2x squared, we get, this is going to be 4x, and then we get minus 6. And so if we combine the like terms here, we're going to get x cubed plus 4x squared plus x minus 6. And that's going to be f of x. Okay, did you see any mistakes that I made here today on this? Yet? No, it looks good? What's a good way to test to see if the proper distribution is done? How do you test that? That's possible, yeah, Bryce, that is possible. But even then you can make a mistake. So how are you going to do to make sure you don't make a mistake on this? Okay, what you'll do is you can enter both of your functions. Okay, yeah, you can enter one right here and one right here. See if they're the same, right? When you do that, see if they've reached the same zeros. Okay, so this is standard form. And then ask the question, see, how are the zeros of f of x related to the standard form of the function? What's your answer to that question? How are the zeros here related to the standard form of the function?
They make the equation?
All right, well, to me, it's not super obvious, right? If you just look at that, now, as an experienced pre-calculus and Algebra 2 and calculus teacher, it is obvious to me, but it's obvious to me from my experience. And from my experience, the relation has to do with this thing right here, this number negative 6, and this number 1. So the ratio, if you take 6 divided by 1, what do you get? 6. what are some of the factors of 6? Right?
Dang.
So that's kind of how they're related. And what this does, it introduces us to something called the, let me erase this first before I go on. It's called the, let's go ahead and figure out the zeros for this first. And so we have this other function here, 2x, g of x equals 2x plus 3 times quantity 4x minus 5 times quantity 6x minus 1. Identify the zeros of this function. And what are the zeros of this function?
Negative 4.
What they're going to be x equals,
Negative.
I'm going to try this in my head, negative 3 over 2.
Yeah.
Okay, so that's one of the zeros. Then we have x equals 5/4.
Alright.
And then we have x equals what?
1/6.
1/6. Okay, so that's really some mental math of setting these things equal to 0 and solving. And you kind of see the signs reverse. So you get, I'm not going to go ahead and multiply these out, but we can kind of see, anyway, we're going to go to this next section here with this called finding zeros using the rational zero theorem. And in my pre-calculus class, we call this by a slightly different name. We call it the rational roots theorem. Rational roots theorem. So that's how we identify possible rational zeros. And basically what you do is you take, well, I'm going to show an example of that right here. So I'm going to just go here to the next thing here. So example 1. So here's the first example we're going to look at. F of x equals x cubed plus 2x squared minus 19x minus 20. Okay, the rational roots, the possible rational roots are found by, I'm going to just put it here, possible rational roots are going to be found by taking plus or minus factors of the constant. What is the constant here in this equation here? In this one right here, in this function, what is the constant?
X.
No, constant is a number.
1.
No, what is the constant in this?
It's a number that doesn't change.
Yes. What is the number here that does not change? 20. That is the constant. The constant is the one without a variable. Okay? Over factors, I'm going to abbreviate factors of coefficient, abbreviate coefficient of first term. Okay, so now I'm going to go ahead and show how that goes. And here they give you the answer, but I'm going to show you how to get that answer. But what we're going to have is plus or minus, what are the factors of the constant here?
2.
2. What else? 10. What else?
4.
4. 5. 1. 20. Okay, so it's going to be plus or minus these factors here. And what's our coefficient of the first term? 1. And so basically what it's saying is, since these are all over 1, we know that our answer for our possible rational zeros, potential rational zeros, are going to be, it's going to be plus or minus, you can put them right in order like they did here, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and finally plus or minus 20. And so what we have here is, how many different possible rational zeros do we have here?
6.
No,
Oh. 1, 2, 3.
not 6, but
12.
12. Okay, plus or minus.
Right.
And so what we can do with this is we can use something called polynomial division to figure out which of these is a factor. And there's also a remainder theorem as well. But basically, it says use a synthetic division table to do the work. And so what we're going to do from here, we're going to backtrack into something called polynomial division. And I don't know if you remember, at the end of the first semester, we were working on chapter 7. We were working on polynomial addition, subtraction, multiplication, and we didn't get to section 7.4, which is division, but we're going to start on that today. So we're going to start learning about polynomial division today and really working on that. So we're sort of taking a side trip, but it's for the purpose of working on these things here. So let's get working on that.
Alright. Is it harder?
Well, I don't know. You'll see. And one of that.
You got a knife? So I get like a little range from my kill one.
Okay,
I think you guys gave that to me, Shane.
what we're going to do,
Yeah. I'll look through my bag and I'll find it.
okay, what we're going to do is we're going to start with problem 2 right here.
You drop it.
Super slow.
That is so disappointing.
It's pretty.
Oh, that's easy.
Pretty dog.
Throw it away.
Okay. All right. So, how many of you, when you were working, when did you learn long division? What grade? Second grade, fourth grade?
Yeah, maybe like first grade.
Fourth grade, right?
Before you do the big box.
Well, what we're going to do is, we're going to do polynomial division, and we're going to introduce today something called synthetic division as well. But polynomial division, what you do, it's just like regular long division, but what you do is you go ahead and you take this numerator here, and you just write it here like 2x squared minus 5x minus 3, and then you put this thing right here. Now let's identify the anatomy of what this is. What do we call this numerator right here? What is that in the language of division? No. Starts with a D.
Denominator. Division. Dividend.
It's a dividend. It's a dividend. And what do we call this denominator here? What do we call that? Divisor. And when we get our answer over here, what are we going to call our answer? Okay, our answer is called a quotient. So that's just some vocabulary. I don't know how much of that's review for you. Quotient certainly is, right? Anyway,
It's great.
Coefficient.
He said the one that doesn't have the
so let's go ahead, what we do is we take 2x squared, divide that by x. What's 2x squared divided by x?
2x.
It'll be 2x, And then we multiply 2x by x, we get 2x squared. And then what we do is we take 2x times negative 3, which is
Negative 6x.
negative 6x. Okay, and now what we're going to do is subtract. So we take 2x squared minus 2x squared is 0. And if we don't get 0 here for the first thing, we know that we messed up somewhere, right?
Yeah.
So what? Then we take negative 5x minus negative 6x. What's that going to be?
Negative 11.
No,
My boy.
the x.
Negative 5 minus 6 is minus, it's negative 5 minus 6.
Yeah, it should be negative 11.
Let's do this. Negative 5 minus negative 6.
Oh,
What is that going to be? Equals 1.
Yeah.
Okay? Now, what you identified for me is sort of a weakness.
oh, that is.
Okay, can you stay with me here? Okay, this is sort of a weakness of this technique. What happens is people have trouble, including people in this classroom, with simple integer arithmetic, right? And that's, and am I being critical of anybody here? No, what it is, I am maybe, but that's a general problem, right? If a lot of people have that problem, that's a problem, isn't it? And so that's why synthetic division is probably going to be helpful to us a little later on. So now, what do? We bring down, what? Negative 3?
Yeah.
Yeah. So wouldn't it be 1?
And then we divide, what's x divided by x?
1.
1, so that's going to be plus 1. Then 1 times x minus 3, we're just going to get x minus 3. So what is going to be our remainder? Yeah, this is our remainder.
It's x minus 3 times 1.
And so now we have what our quotient is, right? How can we test to see if we did this right? We can multiply the quotient by the divisor to see if we get our dividend. Okay? So that's what that is.
So that's the answer?
Yeah, our answer is this right here, quotient.
I don't know.
Okay? So that is our answer right here. Now, one thing they did in the book I'm using here, the workbook I've used these problems from, is they have the numerator wrapped up in parentheses. But that is not absolutely necessary, because when you have a separated numerator and denominator, that assumes that the numerator and denominator respectively are wrapped in parentheses. Does that make sense? Okay, let's go ahead to the next problem. Yes, number 3. So what I want you to do is work on number 3 for a minute, and then so be working on number 3, and we'll go over this here together in 2 or 3 minutes.
No.
I don't want to spin the wheel on this yet.
Why do you like the wheel?
Because I don't know what I'm doing.
Spin the wheel.
That's why you can learn, but.
Yeah, bud.
Yeah, I want you to work this by yourself here, okay? And I'll go over it in just.
All right, now that one. What are you doing now?
You know.
How do you bring that down?
What are these?
Alright, so I'm going to have to make
Be x cubed, bro.
Huh?
Wouldn't it be x cubed?
So,
Squared. Or no? Would it be?
Yeah, I like some of you are helping each other. That's good. I appreciate
I
that.
don't know what to do next. Because I got to the 8 minus 7.
Yeah, I got some 8 on 7.
Yeah.
What's that left?
I don't know. 5x minus
So it'd be
7.
worse.
I do get that. So, I didn't get it. Actually, you set it up. Yeah, I have that. I have that. Okay. I set it up. And then you do x, so x is x is x squared. I'm listening to that. Plus 2, so it'd be 2x. So
Oh, no, I got it.
minus x squared plus 2x would be get negative 5x minus 7.
Yeah, so I got X.
Nothing you just said. And then I would do, I guess 5.
That's wrong.
I would do 5. So plus 5 because 5x. Yeah, negative 5 minus 5.
Okay.
Yeah.
That's
Five.
So you do X.
Minus x. Minus
Ten.
this is you with 2 and 3 is the second. It's going to be negative 3x minus the negative 2. What, Allie, do you have 3 left over? Let me
Yeah, I
see,
have
I'm
three
not
left
done
over from the five.
And then five,
I mean, from the
that's-
10 and the 7.
Okay, what we're gonna do is, I'm gonna show this up here, and so you can help me with this maybe. X squared divided by x is x, and then we multiply through here. We get x times x is x squared, and then we get x times 2 would be 2x, right?
Yeah.
And now we're gonna subtract, and one thing you can do, might help subtraction, is just to wrap that in parentheses. And so we're gonna have 0, and what's gonna be negative 3x minus 2x?
Maybe 5 is.
Negative 5x, and we bring down the minus 7, right?
Yeah.
And so we have negative 5x divided by x, which is
Negative 5.
negative 5. And then we have 5 times x, which is negative
5 is.
5x. And then negative 5 times 2, we have
No.
Unless we get.
minus 10.
I'm so lost. Should be.
And so now we subtract, and so we get negative 7 minus negative 10, which is 3. So this right here is our remainder.
Yeah.
So we have a situation where our remainder,
What do you do after that?
You put a decimal.
and so what we have here, our quotient, in a summary statement of our quotient is going to be like this: x minus 5, then we're going to have plus 3 over x plus 2. So this is going to be answer in summary statement form. Okay, this is our answer. Equals quotient.
Do them all.
And it's a little hard to do, but you can actually multiply this quotient by the divisor and get the original up here. That can be done. But okay, I'm going to mention one other thing. Okay, look at this for where we're going to go with this. This is important what I'm saying. Since we did not find a remainder of 0, what that means, since we did not have a remainder of 0, it means that this x plus 2 is not a factor of x squared minus 3x minus 7. Now in problem 2, since we had a remainder of 0, we know that x minus 3 is a factor of 2x squared minus 5x minus 3. So whether or not we have a remainder other than 0 is a deciding distinction if this divisor is a factor of the numerator or of the dividend, okay? So that's one thing to keep note of, because we're going to be using that when we test out our rational zeros theorem. All right, what I want you to do is take problem 4. And I will tell you, I'll give you a little hint on problem 4. And what happens when you do something like this, you got to be careful about it, because when you have missing terms, you got to go like this. You got to go x cubed plus 0x squared plus 0x and then minus 6. And then you divide by x minus 1.
Why are we doing that?
Dang.
Why are we doing that? I'll tell you why we're doing that. Because 51
51.
is 51 equal to 5001? Are they equal to each other? No, they are not. Okay, so if we just wrote x squared, x cubed without, we have to have all the placeholders represented for this division to work.
Oh, okay. So,
Okay?
does the x is squared, I mean, cube, the one you put in the box, so that's why it has to, yeah.
But what about the other one? Why do we put x?
Okay, I see why, because like
X
when you try to
squared.
do it, you get an x and then you're like subtracting an x from like a normal number and it doesn't work out.
Yeah, well, that's right.
Oh, you're so smart.
That's right. So go ahead and work this one out. We'll go over this in a minute too.
I might need your help, Ellie.
And we may get to synthetic division tomorrow.
Synthetic.
But that's okay.
No. My bad.
Sorry.
You can do back stretches, Bryce? Stretch your back.
I'm not flexible. I can't do that stretch.
It's good for you though.
Oh, good.
If someone, Bryce, if someone here was tall enough to do it, they could actually lift you up and pop your back.
You know what, you're probably right.
Okay, Haley, how's it going, Haley, on this thing?
She's sore, she's hurting this bad.
I'm sorry.
Oh no.
Okay, well, I mean, are you working at it right now? That's my question right now. Right, that's my question. I want you to be working at it
I
right
just
now.
started yours.
Yes.
Ellie, you need help, Ellie?
But I don't know how to subtract that from negative x. So right now I have
So it's x cubed.
negative x squared plus 0x
I don't know.
and then minus
After that.
x squared minus x.
Right, let me pump it
I
back.
don't know.
What did you say?
What?
Yes, yes, yes.
Bryce, what's your back
But
score?
before that,
Why is my back
before you have to do
Yeah.
that one, the first one you did
It's
was
straight
you get
leg,
x times x, which equals x squared.
Oh, you left it go back?
Okay, and then you subtract it,
That's
and
what
then you
it's
subtract
supposed to do.
negative.
Huh?
So now you have negative 4, negative x.
What negative?
4.
Chloe?
I have negative x squared plus 0x, okay, there.
Yeah.
And then when you go to the next one, I have x squared minus x.
Yeah.
Well, subtracting that from each other, you get x to the 4th. Alright?
What am I doing?
Okay, you ready to go over this one?
Break?
Ready to go over this one?
No, no,
Yeah.
easy.
Yeah, break.
Okay, I'll wait another minute and then I'll go over this one.
Yeah.
Now, you see that this one is, number 4 is written differently from the others, right? In this case, they wrote it on a single line as a division problem. Now, in this case, you actually do need to have parentheses to make it work out. How's it going on this, Bryce?
I kind of understand it, but I'm getting caught on some parts of it.
Yeah.
Mr. G, I don't get what's going on, so I'm putting it in.
Okay, so
Okay.
I'm stuck at 0x, the third x. I'm stuck at that third x.
Okay.
That's right.
I'm gonna get that 0.
Okay, let's go and work this out here, okay? Did anybody get an answer where they could multiply by this to see if they get this? Did we get that far?
No, we're stuck.
Okay, so we go ahead and divide out, we have x cubed, right? X squared, excuse me, right?
Yeah.
And then here we get x cubed, and then we multiply by that, we get negative x squared, right? And so we're gonna subtract this. We subtract this, we're gonna get 0 minus negative x squared, which is
Oh, it's positive. Okay,
x
that's
squared, right? And then we're gonna bring down the 0x. And what's x squared divided by x?
X.
It is just x.
X. So we get x squared, and then x times negative 1 is going to be negative x,
Oh, yeah.
and we're going to subtract that out, We subtract that out. 0 minus negative x is going to be x. And then we're going to bring down this negative 6. And so we take, what's x divided by x?
1.
Plus 1. 1 times x is x. 1 times negative 1 is?
Negative 1.
Negative 1. And then we're going to subtract out here.
What are you talking about?
We're going to get
That's negative 5.
negative 6.
Oh, I'm ahead of y'all.
We'll get negative 5, right?
Yeah.
So that is our remainder.
So it wouldn't be a factor.
Yeah, so I'm going to go ahead and give, so our answer in summary form is going to be x squared plus x plus 1 minus 5 over our divisor, which is x minus 1. And Marcus, what was your conclusion out of this, Marcus?
I got 245.
2.5.
No, what did you say a minute ago?
Oh, put in the calculator.
No, what did you say? You said something about being a factor. You said what?
It's not a factor of the equation.
Yeah, so what it is, x minus 1 is not a factor of x cubed minus 6.
This was okay.
Now, what number could we have had instead of negative 6 that would have made this a factor of the other? Negative 1, right? So if that was x cubed minus 1, then x minus 1 would have been a factor of it, right? Because we would have had a remainder of 0.
So if I put negative 1, it'd be...
Yeah. Okay, let's go ahead and look at number 5.
I think this is our last one, Mr.
No, I'll handle that. Just let me handle the timing of the class, okay?
Okay, I was just reminding you.
Thank you. I'm trying to be helpful. All right, this one here.
I think that's next one.
This one here,
You have to add 1 0, right?
we're going to have x cubed minus 6x squared. And then what?
Plus 0.
Plus 0x, good job.
Plus 1.
Plus 1. We're going to divide by x plus 2. So I want you to do that. I'm going to call on somebody. I'm going to spin the wheel on this one in another minute or two. Wait another minute.
Who did squat?
So is it negative 8x or is it positive 8x?
It's plus minus 8x.
So it's x squared minus 8x?
They eggs.
Or positive?
What are you talking about?
What are we?
Negative
4?
What are you talking about? Yeah.
No.
No, it's not negative.
Because you have to subtract that, yeah, positive plus
You have to make the
2x
x not
squared
negative.
turns into a negative because you subtracted.
Really? Really? Is it?
Yes. At the top.
I bet.
Negative 6
And then if
minus
anybody's
2.
talking, I bet.
Yeah, I got positive.
Minus 8x.
Welcome to room 15 where learning comes first.
For buttery?
I'm on the.
Yes, she is. All right.
Hey, you go to us. Oh, Randy.
Really?
Yep.
Miss Dominguez. We'll see Miss Dominguez. You can bring
So
it.
he goes.
You can bring your stuff with you, Rennie. Belson.
Last time it's about the other. And about 3 more.
All right.
What did you do?
Randy, I get the phone now.
Let's go class. Come on.
Wait,
All right,
Just screen will tell you.
who is going to help us with this?
Randy, who did you beat up? Randy, who got the
Okay, here we go.
Yes.
If it lands on you.
Randy. Hey, where you gonna sit down?
Randy, you can go.
It's going in on Mark.
No, it's not.
Yes, it is. Still.
Randy's leaving, she gets chosen.
Yeah.
All right, Siggy.
He don't even know what's going on.
See, he doesn't know what's going on.
All right,
Don't
Siggy.
tell Mr. G what C is.
Yeah, exactly.
X squared minus
Alright,
plus 16 with the remainder of.
Come on, Ziggy, what is it, bro?
31. Maybe 32.
Is it?
Alright, so this is what I got. I got x squared on top, right? And you multiply that with x cubed. And then x squared times 2 would be 2x squared.
Really?
Okay, so you subtract out here.
Like that. And apparently it's negative 8x squared. Yeah. You bring down the 0 x.
Okay.
Yeah, I don't do that thing.
Negative 8x squared divided by x is going to be negative 8x. Get negative 8x squared. And negative 8x times 2.
Negative 16.
Negative 16x.
Negative 16x. Okay, we're going to subtract this thing here. What do we get when we subtract this out here?
Negative 16x.
No.
0 minus negative 16x, I get 16x, right?
Yes.
That is true.
And then bring down this 1. And then negative 16x divided by x is going to be
16.
plus 16. 16 times x, we got 16x. And we have 16 times 2 is going to be
32.
32. And we subtract out here. We get, what do we get?
Is it
Negative 31, right?
Negative 31.
So you get x squared minus 8x, summary statement, plus 16, minus 31 over our divisor, x plus 2, and we know that x plus 2 is not a factor.
Right.
Is or is not a factor? Is not a factor. So we'll leave it there, keep your paper, and we'll just resume on this tomorrow.